This Zoom session is being brought to you by the fractal set of itself. All right, for today, we go through circles and graphs. We start with an equation, y equals f of x. It has a graph which consists of all points x by f of x in the Cartesian plane. For example, the equation y equals x squared will first decompose a table. If x is 2, y is 4, 1 makes 1, 0 makes 0, negative 1 makes 1, negative 2 makes 4. We plot all 5 of these points, but that's only 5 out of really a continuous infinity of points. But okay, if you plot more, you get y, which is what your calculator does, several hundred points or several thousand. It'll create a shape like this, a U-shaped curve called a parabola. I have a question. Where have you seen a parabola in your daily lives? You have. Where have you? Anyone? I can think of, well, several really. Okay, one is
Calculus.
well, I mean your daily life.
Oh,
Your
daily life.
Yeah. Where have you seen things that are shaped like a parabola or move in the shape of a parabola?
Oh, I like stars. They kind of
Stars.
move in a weird way. It's not all of them, some of them.
Well, okay. To be precise, that would be so planets, or let's say comets, orbit the sun in parabolic orbit. So yes, that would be an example. But I mean that's not daily life. But okay, the back.
Ah, fair.
Good. Thank you for chiming in. The back mirror on the back of a flashlight lens. That's a parabolic shaped mirror, parabolic cross section, because if you put the light at a point, special point called the focus, it bounces off form parallel lines. If you throw something across the room, it'll move through the room in the shape of a parabola. That's free fall flight. The before times I would interrupt the class to throw an eraser across the room just for the fun of it. Also, if you look, the cable on a suspension bridge, such as the Golden Gate Bridge, that forms a parabolic shape. Well, never mind. Here's an equation 2x plus 3y equals 6. It will, any equation of the form constant times x plus constant times y equals constant, that will form a line. It's what's called a linear function. Now, in this case, we specify 2 points, but if you set x equals 0, then you can solve for y equals 2. So here's the point 0 by 2. If you set y equal to 0, then you can solve for x, and x equals 3 by 0. So you can join these 2 points with a line, and that is the graph of the equation. Now, all right, there's symmetries of the plane. If you have a point x by y and you flip it through the y-axis, you get the point negative x by y. If you have a point x by y and flip to the x-axis, you land at the point x by negative y. Then if you negate both x by y to negative x by negative y, that's a rotation around the origin. That's because a flip around the x-axis followed by a flip around the y-axis is the same as a 180-degree rotation. So here are some examples. Here's a point negative 2 by 1. Symmetric to it to the x-axis is negative 2 by negative 1 because you changed the y value. To the x-axis, y-axis, you change the x value 2 by 1. Through around the origin, you can change both, negative 2 by negative 1. Here's similar stuff for negative 3 by negative 4, 3 points. This is the point symmetrical through the x-axis. So if xy is on the point, then x by negative y is on the point. This is symmetrical through the y-axis. If xy is on the point, then negative x by y is also on the point. Here's a graph symmetrical around the origin. If x by y is on the graph, so is negative x by negative y. All right. In general, a graph may have intercepts where it intercepts the x-axis. These are called x-intercepts. There where y equals 0 when you solve for x. Here, where it meets the y-axis is the y-intercept. Set x equal to 0 and solve for y. So for example, here's a graph. It has x-intercepts at negative 4, negative 2, 2, and 4. It has a y-intercept at y equals 2. Now, one particular kind of equation is not, okay, up here, I talked about y equals f of x. That's a function graph. It has some specific shapes. It will not, for example, generally be symmetrical to the x-axis because here are 2 different values of y. And these also, here we'll have an equation for a circle. These also will not in general be function graphs, but they will be graphs, equations. We start with a center of a circle, h by k, give it a radius r. We want to know what is the equation for any point x by y on the edge of the circle. All right, so we start off with the radius r, that's a distance. The distance from xy to hk is r. Now, by the Pythagorean relation, or by the distance formula, that distance is root of x minus h squared plus y minus k squared. And that equals r. And the square root is awkward and we don't like it much, so we square both sides and we get this equation. X minus h squared plus y minus k squared equals r squared. That is the equation of a circle with center h by k and radius r. Now you have to sort of read into these a little bit. It's x minus h and a y minus k, so you have to read h and k despite the negative signs. And this is r squared rather than r, so you have to read carefully. So for example, here's a center -2 by center and radius 5. What's the equation? Okay, x minus h squared plus y minus k squared equals r squared. H is -2, y is 7, k is 7, r is 5. Minus a negative is a plus. So this is x plus 2 squared plus y minus 7 squared equals, and 5 squared is 25. So generally we don't stop with this formula. We move on and process it just a bit for to make it easier to read. Okay, so here are some examples. Oh, and by the way, someone pointed out that the odd numbers I cite in these problem sets do not generally match the problem numbers in the homework in the textbook. That's because I keyed this to the previous edition of the textbook, and these odd numbers are a bit obsolete, and perhaps I should go through them and erase them, but never mind. Okay, here are equations. Find equations for the circle with center 4 by -3 and radius 5. Okay, so x minus 4 squared plus y minus a -3 squared equals 5 squared. Okay, we simplify this to an xy plus 3, 5 squared is 25. X minus 4 squared plus y minus 3 squared equals 25. That's called the standard form. However, it's also good, considered a good form to expand this out, expand these a bit. So x minus 4 squared is x squared minus 8x plus 16, y plus 3 all squared is y squared plus 6y plus 9. Then do some transposing and simplifying. We get this. X squared minus 8x plus y squared plus 6y equals 0. This is known as the general form. It'll be in the form ax squared plus bx plus ay squared plus cy equals d. That's the general form. What center, intercepts, and radius for the circle with this equation? 2 times x minus 3 squared plus 2y squared equals 8. Well, these 2's are annoying. Fortunately, they're the same number. If there were different numbers, this would not be a circle equation. It would be an equation of an ellipse. But all right, we divide by 2 and get x minus 3 all squared plus y squared equals 4. And that 4 is 2 squared. So this is x minus 3, y minus 0, and 2 squared. So the center is 3 by 0, and the radius is 2. The center and radius. For intercepts, we set x and y respectively to 0 and see what you get. When x is 0, you get 9 plus y squared equals 4. Y squared would be -5, no real numbers. So there is no real y-intercept. The circle entirely misses the y-axis. If you set y equals 0, however, then we get x minus 3 squared equals 2 squared. So x minus 3 is plus or minus 2. Add 3 to both sides and get x is 5 or 1. So the circle intercepts the x-axis at 1 and at 5. Now here is a little trickier one. Find the equation of a circle with a diameter ending at 1 by 4 and -3 by 2. Okay, here we draw a rudimentary diagram, 1 by 4, 3 by -2. Okay, first we need the center and we need the radius. Okay, the center, that's easy. This is a diameter. Therefore, the center is the midpoint between those 2 points. So we add coordinates, -3 plus 1 over 2, 2 plus 4 over 2. That gets you -1 by 3. There's the center. For the radius, let's take the distance between the center, -1 by 3, to 1 by 4. We could also take the distance between a -3 by 2 and 1 by 4, but then I have to take half of that at the end. Let's do this. Okay, from 1 by 4 to -1 by 3. 1 minus -1 squared, 4 minus 3 squared. So this is 2 squared plus 1 squared. After a bit of working, it's root 5. That's the radius. So the equation is x minus -1 squared plus y minus 3 squared equals √5 squared. After a little bit of calculating, it's x plus 1 squared plus y minus 3 squared equals 5, and that's your equation. Now, okay, this one, I think they were trying to force you into doing some algebra, but really this is easily done by visual geometry, and a lot of these problems in this book can be done that way. So we have a circle, and in it we inscribe a square. And the circle has equation x squared plus y squared equals 9. Find the area of the square. Now, okay, 9 is 3 squared, so the radius is 3. So this is 3, this is 3, this is 3, this is 3. All right, I could find things like find this distance here, therefore double that to find this distance here. It's this distance here and this distance here. Multiply it out to get the sky, to get the area. But I think it's just as easy to start with this picture, then break it up into four half squares. Join up these two to this, join up these two to this. Here, 2 squares with side 3, and the area is twice 3 squared, which is twice 9, which is 18. And if I'd gotten by finding this distance, then this distance, you would have found this distance here is √18, which would be 3√2. Another matter for elsewhere. Well, okay, I believe we've finished our section for today.